Hello and welcome. In this video, I'll show you how to model an air heater using COMSOL Multiphysics. In this model, we have an inlet airflow and an outlet flow. The bottom and the right boundary are set as symmetric, while this boundary is defined with heat flux condition. To start the modeling, let's mount COMSOL. For the start the model, click on Model Wizard. In this example, we have a 3D dimension, so click on 3D. Okay, here we have a turbulent flow, so click on Fluid Flow, Single Phase Flow, and click on Turbulent Flow and select turbulent flow epsilon. So add it. And now let's mount to heat transfer and select heat transfer in fluid and click on Add. Okay, now click on Study. In this example, we have a steady state simulation, so click on Stationary and now click on Done. Okay, in this example, we need to create our geometry or our domain. So right click on Geometry and select Work Plane. Okay, now click on Plane Geometry. Okay, here we select a circle. The radius is 0.1 and we have only 90-degree sector angle, so click on Build Select. Okay, now right click on Work Plan, and here we need to insert our length of our solar heater, so click on Extrude, and here we have 1 meters for length, so click on Build Select. Okay, now let's move to materials. Right click on Material, add material from library, and here let's mount to liquid and gases. Click on gases and select air. Okay, add to component. Now let's mount to turbulent flow and right click here because we want to define the boundary condition. So right click on turbulent, select the inlet boundary condition, and our inlet velocity is 1 meters per second. And also right click on turbulent flow again and select the outlet. Okay, now again right click and select symmetry. This boundary and this boundary are symmetry. Okay, and now let's mount heat transfer and follow it. Right click, select temperature. This boundary is our inlet. So here, as you see, this boundary is our inlet. So here back on temperature 1, and it is 300 Kelvin. Okay, now select the flow condition and select outflow. So it is our outflow. And now also we want to create the symmetry boundary condition. So select symmetry. Okay, select this boundary and this boundary. Finally, we have heat flux. So right click on heat transfer and fluid. Select heat flux. Select this boundary, and our heat flux is 1000 watt per square meters. Okay, now select fluid 1. Okay, the velocity fields come from the turbulent flow. So here select the user defined and select velocity field from SPF. So here you see that the turbulent flow is SPF. Okay, now let's move to mesh 1 and click on build on. Okay, it is our mesh. It is a boundary layer that's created to capture the velocity gradient and temperature gradient near the wall. Okay, now let's move to stationary 1 and click on compute. Okay, the run has been completed. So now we want to check our result. So here, as you see our velocity distribution, as you see. So we can change the direction about the distribution. So here, we click on a slice, and here we use another pattern, for example, x y. Okay, it is our velocity distribution, as you see. Now we want to check the temperature distribution. Again here, right click and select slice. Okay, and select XY plan and click on plot. Okay, also delete the volume 1. Okay, now click on slice 1, and here we use T. Okay, it is our temperature distribution. You can use degree C for the temperature unit.